Hi, Assalamualaikum. My name is Farah Adriana, and for part A, I will summarize the data sample for Lajakkuruih-F. The first one is the summarization for each category regardless of the shift with numerical method. Okay, by using the function in Microsoft Excel, we find the mean, standard deviation, variance, and mode for each category. And then, using function frequency, we find the range frequency for each category. Okay, the first one is width. The highest frequency is 53, between 350 until 360. And for relative density, the highest frequency is 78, between 86 until 88. And then tensile, the highest frequency is 70, between 7.1 until 7.2. Okay. So for the shift, we use function count to find the frequency. Okay, so for morning shift, the frequency is 75, followed by evening 67, and night 58. Okay, so from here we find that the morning shift has the highest rate of production, which is 75, and this can be proven by using pivot table to find the sum in each category. Okay, so in this table, we can see that the morning shift has the highest sum in each category. Okay, and then we also find the average and variance for each category. Okay, for the average of weight, the evening shift has the highest average, and for relative density and tensile, the morning shift has the highest average. Okay. Next is variance. Okay, so for variance of weight, the night shift has the lowest variance, which means in terms of weight, the night shift is the most consistent. Okay, so for relative density, the lowest variance is in morning shift, and same with tensile strength.
So, Assalamualaikum. My name is Soleha and I will discuss the solution for question B. The question B asks whether there is significant evidence that Lajakkuruih tablets produced in December 2020 regardless of shifts do follow the normal distribution with mean of 350 mg and standard deviation of 14 mg. So we know that the mean is 350, standard deviation is 14 and the variance is 14 squared. And then we put it into this form. The first step we need to do is make a hypothesis statement. Hash note is Lajakkuruih tablets produced in December 2020 do follow normal distribution with mean of 350 mg and standard deviation of 14 mg. For the H1, Lajakkuruih tablets produced in December 2020 do not follow normal distribution with mean of 350 mg and standard deviation of 14 mg. So the second step we need to put the data in specific range, and then we will get this table. And then we need to transform the x value in z term by using this formula, z equal to x minus means divided by standard deviation. After that, we find the proportion, and the summation of proportion is going to be equal to 1. So this is the table to find the k value, observed frequency, expected frequency. So to find expected frequency, we use the formula n times with the probability. We must take note that expected frequency must be more or equal to 5. So when we look at this, 0.44, 2.8, both are below 5. So to solve it, we need to add both values together. We will get 3.24, but it's still below 5, so we must add again to below data. So we will get 15.28, and the new k will be 1. the new observed value will be 17, which is the summation of 1 plus 4 plus 12. And for the other range, there will be no problem because the expected frequency is above 5. But for the last data, 3.24 is below 5. So we need to add it with the above value. So we will get 15.28. And the new key is going to be 6. And the new observed frequency will be 15. So the summation of all the observed frequency will be 200. The summation of expected frequency will be 200. And to find chi-square test, we need to use this formula. And then we will get this value for each range. So the summation of this value will become our chi-square test, which is 2.4091. So the decision rule is we must reject H0 if chi-square test is bigger than chi-square alpha 0.05 with degree of freedom 5. When we look at the table, we will get 4.3515. From previous calculation, we get our chi-square test, which is 2.4091, which is below 4.3515. So we fail to reject H0. Therefore, Lajakkuruih tablets produced in December 2020 do follow normal distribution with mean of 350 mg and standard deviation of 14 mg.
So for question C, we're going to comment on whether there is any significant difference between the tablet weight from the different shift. So from this Excel, first things first, we need to organize the weight column and shift column, which shift column consists of 3 different shifts, which is morning, evening, and night. So we're going to organize the morning column, evening column, and night column. After that, we're going to make an analysis of variance for one way, since this is a single factor ANOVA. So from that, we get the summary for morning, evening, and night, the count, the sum, average, and variance, and also the ANOVA table, which is the source of variance, variation, so sum of square, degree of freedom, mean of square, f-test, p-value. Between groups means the treatment, and within groups is also the error. So from this ANOVA table, we get the f-test, which is 0.1161, and f calculation 3.0418. P-value also we get 0.8905. So we need to make an hypothesis statement for H0. We're going to assume there is no significant difference. So mu1 equals to mu2 equals to mu3, which mu1 is the morning, mu2 is the evening, and number 3 is the night. So H1 is mu I not equal to mu j for at least one. I not equal to j, there is a significant difference. So from the table f-test, we get f calculation also we get. So if f-test less than f calculation, we need to accept the H0. Also, p-value is much more larger than alpha itself, so we also need to accept the H0. So in conclusion, if f-test less than f calculation, there is no significant difference between the two tablet weight from the different shifts. Thank you.
Hi, my name is Nurul Nadira. Now I would like to discuss about the tablet hardness. As you can see here, tablet hardness can be explained by two variables. Relative density is known as independent variables, while tensile strength is known as dependent variables. We use Microsoft Excel to perform the simple linear regression. This is the result that we get based on the data given. To confirm that we insert the correct value, we can see the observation part here. It shows that 200 as it's same with the sample size. Then we can see the intercept is 0.261 and the estimate slope is 0.0782. So we will get the regression equation as y equals to 0.216 plus 0.0782x. Next, as you can see here, we can get the value of correlation coefficient, that is 0.8447, and it is near to the 1, the unity. So we can conclude that this will form a strong positive linear relationship between relative density and tensile strength. We can also check the confidence intervals for the relative density from the data. So we can see here the 95 of confidence interval is 0.07126 and 0.08515. So by using hypothesis test, we can test the significance of regression where the relative density is different from 0. In this case, the alpha is 0.05. From this table, we can see here our significant F is 1.17252 E negative 55. When we compare both value, we can see our significant F is smaller than alpha, so we will reject H0. This will conclude that the data provide a strong evidence that linear significance exists between X and Y. That's all from me. Thank you.
Okay, Assalamualaikum and hello everyone. My name is Izul and now I'm going to make a general conclusion from the data that we obtained. So this is the normal probability plot. As you can see here, the data is captured along the straight line. So we can conclude that the normal assumption that we made is satisfied. Okay, next is the relative density residual plot. As you can see here, the data is sketched along and near the zero. So from here we can conclude that the normal assumption that we made is satisfied. Okay, last but not least is the relative density line fit plot. So the blue one is the tensile strength and the orange is the predicted tensile strength. So the model is valid because the positive linear is the same as the hypothesis test that we have confirmed before. So that's all from me. Thank you.